we have all gathered here for a case study discussion on BJT bias compensation technique. So the problem statement here is I am going to consider an environmental monitoring system, which is a IoT based system. So here we are going to make use of analog gas sensor. So the signal which is produced from the analog gas sensor, the amplification will be affected due to the thermal properties, that is the atmospheric climatic conditions would increase the temperature. So due to that the device would get damaged and the proper output signal will not be received. So here you are going to find out the various challenges behind this in identifying the best bias compensation techniques, and you give me the better solution of bias compensation technique to overcome such type of thermal issues. So I will give you 5 to 10 minutes. You can discuss among yourself and find out the better solution.
So hello everyone, now we are going to speak about the problem statement of to making the bias compensation technique. So our problem statement is here. We are taken as an example of gas sensor which is used in the environmental condition to check the environmental condition using gas sensor. So by the external temperature, the gas sensor might be heat at the particular temperature to the temperature must affect that sensor.
Gas sensor will detect the leakage in gas. So in environmental monitoring system, we are making use of gas sensor. So the problem here is the temperature affects the gas sensor.
So the temperature affects the gas sensor, so that we can't get the exact value of the gas leakaging. So for that we have to find the solution for bias compensation technique.
Compensation techniques, the second method is emitter degeneration. In emitter degeneration, a resistor is added in the emitter. It introduces the negative feedback, and as current rises, the emitter voltage increases and reducing VBE. This bring back the control under the control. The third method is thermal tracking diode. A diode is thermally added to the
diode is included in the circuit.
The diode is included in the circuit, and it compensates the temperature dependent drop.
To implement the bias compensation techniques, that is, the first one is voltage divided bias. Under this, it is the most usable and bias composition in for BJT, that is bias junction transistor, and it falls under the bias composition techniques. That falls it uses to help stabilize the operating point of the transistor, and it against the temperature and beta, that is current gain. And the advantages of this is, the first one is it has temperature stability, and the second one is beta impedance, and the last one is Q point of the temperature.
So let me talk about the challenges. So our topic is all about the increase in temperature of the system and the gas affecting the gas sensor. So the first point is that main challenge is that thermal drift. The thermal drift is that the voltage, DC voltage decreases for 2 microvoltage per degree Celsius, which causes a serious and very high decrease in output voltage. And the second point is that Q point, as the base emitter voltage changes in time due to the change in temperature and other areas, the Q point of the transistor also changes, and it affects the amplifier. Is that there is no negative feedback. That is, when we don't place a resistor in the emitter, the IC, that is the current in the collector, decreases, and this causes a major effect in our process. And the last challenge is that
include resistance in the emitter for stabilization purposes.
And when we implement resistor in the emitter side, it stabilizes the collector current, and we use that for that. And the last point is that environmental changes, and the environmental changes, as we all know, it increases the temperatures and affects our process. These are the common challenges we face in our process.
This method ensures a reliable analog sensor perform in a harsh outdoor condition without then any active thermal conditions used in it.
So thus, as per the discussion, by including temperature sensitive devices like thermistor, transistor and diode, we can compensate the temperature effects which is produced in the analog gas sensor. So thank you all.